Welcome to Spring LIB.
We're asked what the smallest possible area of the triangle that is cut off by the first quadrant and whose hypotenuse is tangent to the parabola y equals 4 minus x squared at some point is. Sort of a long question. Well, first of all, we have our parabola y equals 4 minus x squared, and the derivative is the slope of the tangent line to y at x. So y prime is negative 2x. This is our slope at x. Now the area of our triangle A is going to be 1/2 times the base B times the height, where the base B is the distance from the origin to the x-intercept, and the height is the distance from the origin to the y-intercept. Now we know that the tangent line to y equals 4 minus x squared at some point, let's say x equals p, well, this contains the point p 4 minus p squared, and so the tangent line is y minus 4 minus p squared. This is equal to the slope, which is negative 2p times x minus p. So solving for y, we get y equals negative 2px plus p squared plus 4 Now we can find the y-intercept by plugging in x equals 0. This is the point 0 and then p squared plus 4. And the x-intercept of this line, we set y equals 0. This is negative p squared plus 4 over negative 2p, which is p squared plus 4 over 2p, 0. Now we'll substitute these into our area equation, so we can write our area equation as a function of p. So area as a function of p is 1/2 times our base, which is p squared plus 4 over 2p, times the height, which is p squared plus 4. And this eventually simplifies to 1/4 p cubed plus 2p plus 4 over p. Now, in order to minimize this area, we're going to take the derivative. A prime of p equals, this is 3/4 p squared plus 2 minus 4 over p squared. And we want to find when this is equal to 0. If we solve this rational equation, well, we can write this as 3p to the 4th plus 8p squared minus 16. Over 4p squared equals 0. In the numerator, we have a quadratic in p squared. We solve this using quadratic formula. P squared equals negative 8 plus or minus the square root of b squared, which is 64 minus 4 times a, so 4 times 3 times c, which is negative 16, all over 2 times 3. And this simplifies to negative 8 plus or minus the square root of 256 over 6. Now, p squared, of course, has to be positive. The only way this is positive is if we have negative 8 plus root 256. So we're only looking at negative 8 plus 16 over 6, which is 4/3. And therefore, we have that p is equal to, and once again, because we're in the first quadrant, p has to be positive, so p is the positive square root of 4/3, which is 2 over root 3. Now, of course, if you test a prime on intervals to either side of 2 over root 3, you should find that a prime of p is less than 0 for p less than 2 over root 3, and that a prime of p is greater than 0 for p greater than 2 over root 3. And by the first derivative test, it follows that a has a minimum at p equals 2 over root 3. Plugging in the value of p to our area equation, we get that area at 2 over root 3, this is our minimum area. This simplifies to 32 root 3 over 9 after a few steps, which is approximately 6.1584.